Okay, so fission versus fusion. Fission at the moment we're quite capable of here on Earth, and in fact many countries use fission to subsidise or essentially power their cities. Um, Fission reactors have been very successful. There are lots and lots of them around the world. We have had some problems, uh, namely Chernobyl, 3 Mile Island, and Fukushima more recently. Um, Something called meltdown can happen, and that's particularly nasty. Um, what about fusion? Fusion's is great, in fact. Okay, so benefits of um, one of the benefits of fusion is that we have lots and lots of this fuel, of the fuel that's required. Where we need uranium here, we only need heavy water here. So um, for in fusion, um, we need deuterium. Uh, and this is abundant on Earth, actually in seawater. Seawater contains uh, 0.03 grams, 0.03 grams per litre, and it's calculated that there's enough uh, deuterium in the ocean to last about sustainability um, about 1 billion years. Yeah, that's right, billion years on Earth. We probably won't be here when that runs out, if we got fusion to work. Uh, Waste products in fusion, in fission, nasty, very nasty. They have to be kept away from human beings for a long time. Waste products in fusion, generally not radioactive. Um, uh, it's helium, normal isotope of helium that we make. So the byproduct, we can blow up lots of balloons. Meltdown, meltdown that we associate with fission reactors um, will not happen. The reactors that we're talking about for fusion, um, well, for starters, we're not relying on radioactive fuel nor byproducts, and so even if meltdown did happen, so essentially what meltdown is when the thing becomes too hot that it melts, the core melts. If it did happen, we're not releasing radioactive products into the atmosphere or into the area. So even if it did, we've destroyed a core essentially, but it can't because plasma, we basically get plasma, and I'll find a picture of what our fusion reactors look like at the moment. Plasma uh, is not very high temperature, still very high, and the total energy is low. Um, let's find a picture of a fusion reactor. Internet's working. Yes, good. So this is the interior of a, once my computer catches up here. This is the interior of a fusion reactor, or what is called a tokamak at the moment, tokamak. Essentially, it's the plasma is kept in a donut shape. And these are all basically magnets to keep those charged particles. Remember, a plasma is just made up of charged particles or ions, and keeps that plasma in like a nice donut shape in there. Okay, this is how we house that reaction. We keep that reaction from being uh, coming into contact with anything, because it is very hot still. Tokamak is what it's called. Tokamak, I think that's right. And so uh, we can't. The issue with this is essentially an issue. Actually, I'll write this. An issue is that we can't sustain this reaction. We can get the reaction to happen, but we have to put so much energy into this tokamak to get the fusion to take place. We get a little bit of energy out, but it doesn't outweigh the energy that gets put in. Issue with fusion. We put simply, the simple way to say it is we put more energy in than we get out. Now, so we can get fusion to take place here on Earth. We can get the temperatures high enough, um, but we can't sustain it, and it's not efficient. The other issue is you can get the fusion to take place, to begin the fusion reaction to start, but then it very quickly stops. It doesn't sustain itself. It won't self-propagate. Kind of like pouring petrol down a carburetor to get a car started. Sometimes you pour the petrol in, the car starts straight away, but then runs whatever was the problem before takes over, and the engine stops again. Okay, so you get the fusion to take place, and then it stops. Fusion takes place, then it stops. Lots of energy in, very little, or not so much energy out. Um, Fission, however, uh, high energy density in the uranium. It's plentiful. You know, with using plutonium, it might last us about 2,000 years. They say about 100 years with the uranium that we have on the surface of the planet. Um, Really nasty byproducts, however, and we're still not sure what to do with them. Uh, it's uh, it's a huge issue. But the other thing is, I believe it's probably better than coal-fired power stations, with the issue that we have with carbon emissions today. Thank you for watching.